Let's move on to question number 22. If we look at what this one's telling us, a ball is thrown from an upward height of 30 meters per second at a speed of 20 meters. Right. So let's go ahead and put this in. What do we know? Our height, our initial height, x0 equals 30 meters. We know, what else do we know? We know our v0 is 20 meters per second. Right? That's all that that problem told us explicitly, but we do know some other things, right? We know that gravity is acting on this, and we know the acceleration due to gravity is negative 10 meters per second squared. So again, those are the things we know. What is it asking us to do? We're asked to find the ball when it reaches its maximum height. What is its maximum height here? What does that tell us? This tells us that at that point, our velocity equals 0. Key point. Remember this key phrase, maximum height, that tells you our v equals 0. So if we want to just look at the time it takes for the ball to be when it's thrown to reach its maximum height, we know that our velocity at that maximum height is 0. Right? And our problem is asking us to find delta t. Right? So now we have lots of variables. Let's plug them into an equation that will give us an answer. Again, we're looking for time here. And the equation that would best work for us, right, is we know that A is equal to delta V over delta T. So if we can rewrite this, so it's solved for delta T, delta V over A. What's our delta V? We end up with a 0 for our final velocity. Our initial velocity was 20. How long did it take us? What's our acceleration? Negative 10. What's this give us? This gives us 2. And since we're talking about time, and we're measuring time in seconds in our equation up here at the top. Part B, what is the ball's maximum height? Well, let's add to our variable list. Now we know that our t is 2 seconds. Our 2 seconds. Now we're being asked, what is our height? Right, so let me back this up. I don't want to say we're looking for delta x. We want to know what x final, x at the top is. Right? What is our x final here? What is the ball's maximum height? So can we figure that out? Right? We've got an x0, a v0, an a vf, and now we also know delta t. So we can use our equation that's on the bottom left. We have all that information here, right? xf is equal to x0 plus v0t plus 1/2 at squared. So let's go ahead and plug in our numbers and see what we get. All right? x0, 30 meters. Right? v0 is 20 times 2 seconds. Right? Plus 1/2 of our a. Our a is negative 10, so 1/2 of a is going to be subtracted from -5. What's our t here? Our t here is 2, so we're going to square that 2. Right? Let's add these numbers together here. 5 times 2 squared, 4, minus 5 times 4, 20. So we've got a negative 20 there. We have a 30 plus 40, 70 minus our 20. This is going to give us 50 meters. Okay. How long will the ball be in the air? How long will the ball be in the air? There's 2 ways we can do this. I will take a moment and I will show both. The first one is the easiest, I think it's the easiest one from a math perspective, but it doesn't help as much from a pictorial perspective. We'll come back to that. So for the math perspective, let's go ahead and let's use the same equation we did here in part B. Let's do xf equals x0 plus v0t plus 1/2 at squared. So now if we're asking how long will the ball be in the air, right, that's telling us when the ball hits the ground, we know that its position is 0. Its x final is 0. So we're going to plug in a 0 for our xf. We know our initial x was 30. We know our initial velocity was 20. We don't know our time yet, so I'm just going to leave that in there. And we know 1/2 a, that's going to be -5. And again, our t squared. Okay. So let's plug this into our quadratic equation. Again, remember we're doing our quadratic equation. The a is the coefficient for the t squared. The b is the coefficient for the t. And the c here is the one that doesn't have a t. So let's plug this into our quadratic equation. Time equals -b, so that's what, -20, plus or minus the square root of b squared minus 4ac. But because a is negative, right, we're going to be adding, there's our 4, there's our 5, and there is our c, our 30. Okay. So let's go ahead and let's plug in these numbers. Oh, got to do the bottom part here over 2a. What's a here is -5. 2 times 2, that's going to give us a -10. So let's plug this in. Let's look at our two different roots here. Well, let's expand. Let's figure out our radical first. Right, if we look underneath of our radical, what's this going to become? Let me use a different color here to kind of offset it. This is going to be the square root of what? 400 plus 4 times 5 is 20 times 30 is 600, right? So we have the square root here of 1,000. What's the square root of 1,000? Square root of 1,000 is 31.6. Okay. So let's plug that into our t equation that we have over here. T equals -20 plus or minus 31.6, and we divide that by 10. If we plug in our different values here, which one we're going to take, right? We know that we're looking for a time that's in the future, so we know we want a positive time here. One of these roots will be negative. One of these roots is going to be negative. We know that happened in the past. It happened before we threw the ball up in the air. So we're interested in the positive root here. How can we find our positive root? We want our denominator is negative, so we want our numerator to be negative. How do we get our numerator to be negative? Let's look at the one where we're going to subtract that 31.6. Right? So -20 minus 31.6. What are we going to get here? We're going to get -51.6. Right? Divide that by -10, and this is going to give us 5.16 seconds. Again, we wanted the negative root here. We wanted the negative root here because we're looking at time that's in the future, not time that is in the past, right? So we wanted that negative root. Let me try doing part C in a slightly different way. Let me do this a little bit more graphically to show you an alternative here as we go through. So I'm going to erase everything I just did using the base equation. I'm going to show you what I think is an alternative way that I think is very helpful as well. Use whichever way works best for you as far as your thinking goes. So let's look at this, again, using a slightly different perspective. How long will the ball be in the air? Well, we already know what? We know how long it took the ball to get to the top. 2 seconds. 2 seconds. Right? So now what we really need to do is we want to figure out how long does it take the ball to come back down and hit the ground. So if we want to do that, we can plug in some variables. Let's look at let's start with our time 0. Let's start where it's at 2 seconds. So what do we know here? We know our V0 is equal to 0. We found out up above, right, that our X0, what was our maximum height? That was 50 meters. We know we're hitting the ground, so we know XF is going to be equal to 0 meters. We also know that our acceleration is due to gravity. -10 meters per second squared. So we've got a V0, we've got 2 X's, we've got a G. We're looking for a time. We're looking for a time. Can we figure that out? So knowing this, how can we find the time it takes to go here in the second part of our trip. How long does it take to fall down? Again, we could use that same kind of base equation we were using before. XF equals x0 plus v0t plus 1/2 at squared. But let's plug in our numbers from this time, right? We know xf is 0. We know x0 is 50. Our v0 here, our velocity was 0 at the top, so that term falls off. That's really nice. That gives us a 0 here. 1/2 a, that's going to be our -5. Right, our 5t squared. Okay, so let's go ahead and solve this. What do we have? 5t squared equals 50. T squared equals 10. T equals the square root of 10, which is going to be 3.16. Right, so we add that to the time that we have on here, right? So we know this time was another 3.16 seconds. So we know our total time to fall, right? We just have to add those together. It's 5.16 seconds. Okay. So we get the same answer whether we do it with this pictorial, doing the first half, second half, or whether we do the whole long equation, xf equals x0 plus v0 delta t plus 1/2 at squared. Two different ways. Let's move on to section D. I'm going to erase this last little part here because I want to make sure we have plenty of room. Let's move D up a little bit. What will the ball's velocity be when it hits the ground? What will the ball's velocity be when it hits the ground? So again, we can figure this part out. We know it's going to take 3.1 seconds to hit the bottom. Right? What do we know here? We know our V0. If we take it from the top, right, our V0 was equal to 0. Our x0 again is equal to 50. Right? We know our A is g equals -10 meters per second squared. And we know xf is equal to 0. We're looking for vf here. We also know what? We also know that delta t from the top down is 3.16 seconds. Right? We either got that from doing the first half of our loop and the second half of our loop, or also noticing that we calculated the total time was 5.16 seconds, and we knew it took 2 seconds to get to the top, so that left us the difference, 3.16 seconds to fall to the bottom. Well, if we know A and we know T, we can figure out velocity when it hits the ground. Vf is equal to V0 plus A delta T. Right? We knew V0 was what? 0. We know A is -10. We know our T to fall down here was 3.16 seconds. So we know this velocity then is going to be -31.6 seconds. Meters per second, rather.